Hello, everyone. Hello. Let's see here. Oh, it's a cable tie. So, let's see what we're doing today here. I have a, let's make that a bit smaller. I have this little D3D12 thingy I was working on. And I thought we'll do some more stuff on that and talk a bit about some funny things happening. So this is just a window, and there's nothing interesting going on here really to look at. There's one big rectangle that's gray, and there's a smaller one on top, and that's supposed to be some kind of menu bar. I'm just trying to do some basics for some game engine style tools UI, kind of. Right. So, what we're gonna look at a bit today is shader reflection, I think. So I have currently this set up so that there is this shader, right? Shader.hls, this one, yeah. And this shader has some constants and funny things going on up here. There's like this structure buffer. I'm not sure if structure buffer is the correct thing to use here. I want sort of a buffer of structs. I read something that maybe it's not the right thing. But I'm not sure. There's maybe some size limit to it that I haven't really understood, but we'll see. And then I have a constant buffer. So I have a constant buffer up here and a structure buffer down here. And currently it's hard coded how those are sort of fed data. So I just thought that we maybe could make that less hard coded. Or at least take it out of the renderer, sort of. So that's what we're doing today. We can put the chat over here, maybe. So I can focus on this. Right. So I have in the renderer D3D12 file here. I have there's, for example, if you look at the shader.hsl, we have UI elements here and this constant buffer. This MVP thingy it's filled here. It creates a buffer here, and it creates a resource for the buffer, and then it sort of maps that memory up, and then it sort of feeds in this stuff all the time. It's MVP stands for model view projection. That's usually what you have in 3D. This is just, of course, just for UI. But yeah, we will see if that how we do things. Hello, channel. I think I put the chat. I'm a bit unsure. I should get one of those fancy sort of chats, you know, that's on the screen but not really on the screen, if you know what I mean. Like that. Anyways, because now it's sort of completely blocked. There's this, you can get like transparent see-through. I know Twitch people have that. I don't know how you do that for YouTube, because I always had this problem where I kind of ruin my own screen real estate. But I also don't see the chat if I was on the second screen. So anyways, so this we could, I don't know which one to well, let's start with the constant buffers maybe. So the way this works, the way it knows where to feed these things, because we have this MVP equals, like we have it down here, right? Here it makes this matrix that it feeds in here, and it copies it into a mapped memory area. And that map memory area goes into this constant buffer thingy. How does that work now again? Well, let's see. We have the script. So the Direct3D has all this kind of this concept of the descriptors that tells you how something looks on the GPU, some kind of resource on the GPU, and this is sort of the main thing that people sometimes find a bit hard, and I still find it's essentially you have so much control that you can do anything, but then you're like, you don't get any help because you can do anything, kind of. It's the same, you have the same thing in Vulkan and stuff, essentially. Well, at least similar stuff. Just trying to find my way around in this pile of code here. So we have this thing called descriptor ranges, right? There's a thing called the root signature. And in there we feed a list of root parameters, and one of those is a descriptor table, and that one says which sort of descriptors are available to the shader and stuff. And we have two different ones, CBV and SRV, and we see that there's one in each, and the register space is 0. Now what that means is that in here we say B0. This is the, unless I'm misremember, the B is for the constant buffers, and 0 is that's the shader register. We could also put, I think you can put space or something here. I don't remember exactly the syntax, and then you would get a separate sort of space of registers for those. So if you have collisions or whatever, so you can do that. So this is number 0, and this T here is for the shader. SRV is shader resource view, and this is constant buffer view, I think. So constant buffer view, shader resource view, and the T is the stuff that goes into the SRV thingy. So I have one descriptor in that one and one in here. That's just hard coded like that right now because I only need that. And then, hello Llama Toast. And then let's see, what more do we have? Then we have a heap of descriptors, right? Yeah, so we have this thing here, CBV descriptor heap, that we create here, and we say there's two in it, and this one is for all the constant buffers and all the shader resource views, so they all go into the same thing, right? And so the position you put it inside this one, it decides which one it maps up to. So we have, well, let me see. It's a bit of a, so we have here, right, that this one is like, okay, we start, you could think of this thing here, the descriptor ranger set, because we also feed in, when we do the later, we say set descriptor heaps. We say here, here we feed in the constant buffer descriptor heap. So we feed that one in, and you can think of it that one should match that one should match the sort of descriptor ranges, right? So you say that, okay, first there's gonna be the first thing, there's gonna be some constant buffer views in the descriptor. That's the first descriptors. There's gonna be 1, and they are in this space here. I at least this is how this is from my tests. It's like, this is how I think it works based on what I've come up with from testing it a bit. And then the offset append here is just that this seems to, we can look at what this one what this one actually does, but why is there no... Oh, there it is. Okay, yeah. Yeah, so this append range here means that it should follow the previous one. So we have essentially, first we have one constant buffer view, and after that we append the shader resource view, and we have one of those. So that's what it expects there to be in the descriptor heap. So that's why, and this is sort of the last puzzle piece of this, right? We have get, what's it called? Is it here maybe? Yeah, so here's the constant buffer, and that one was first. Remember, there was, if we look at, where does it go? Where does it go? I'm gonna close. This is what I do whenever there's too many things. I close all tabs, close everything, and like that. So the constant buffer views are first, right? So we this, if we think of the descriptor heap as just a list of things, then we assume that at the sort of base offset of 0, there should be the thing related to the first constant buffer view. When we only have one, so that will be the one in the shader. That's this one here, this whole C buffer, which is only one matrix right now, right? And then, so then we have the what's it called? Yeah, this thing here. So here this is what I showed at the start. Here it creates the constant buffer, the constant buffer, and then it makes a view here, and these views are cheap to make. This is like, these are many of the sort of how to say, mystical thing about direct 3D12, right? That it's not, you don't find very much information about, like, okay, constant buffer view, or this view itself. How often can you make that? Does that imply some kind of allocation? Is it, what's the best practices here, right? And I had to ask on the DirectX Discord, which is actually surprisingly good. There's a Direct 3D12 or DirectX 12 channel there, and people actually have good suggestions there, which is, and there seems to be some Microsoft people even there, so it's quite nice. Yeah, and then, but anyways, the constant buffer view. So this thing, you actually, here, this is inside, let me show you where this is. This is inside create pipeline here, which is where I sort of, currently I feed in a shader handle here. This is all gonna change a bit at least. But I wouldn't necessarily need to create this view here and then keep that forever. I could also create it on the fly because it's quite cheap to make. But the main thing here is that I take the CBV code descriptor heap and I say, give me the handle for the heap start. That's the start of the heap. And then you see, I don't do anything more with the handle here. I just say create constant buffer view at the handle. And here's my constant buffer view description, which is for the constant buffer. And I say, put it at the start of the heap. And then I map up the memory, and the reason I map up the memory is just so that I can copy in the actual data later. I keep that mapping open. And this constant buffer here is, you see, it's exactly the same as, is a 4x4 matrix here and here. It's aligned to 256 bytes of memory because that's what constant buffers require. Anyways. But the interesting thing here is that then we come to, there's another one here. I mean, there's both, these are just structs, but this is just struct definitions, but there's another sort of thing here that goes into the SRV, the shaded resource view at register T0 here. And that one is the other one I showed, which is this one. And since there's only one descriptor here, then you could think of it like, okay, at the slot just after the first one, there needs to be there should be there's room for one. The thing, there's one descriptor for at register space 0, which is the space this one is in. So if we feed something into this slot here, then it will get put into here. I will describe what this one is. And this just describes, I mean, you create the GPU resources separately, and so you create GPU resources, upload data, and then you somehow need to tell it like how the shader should get to that data, and that's the descriptors, right? It describes the resource on the GPU. And then, so that's why we have another one here. Here is, and currently I do this in begin render parse. This is something we're going to change here. But we're essentially saying, okay, we make a resource shader SSRV, shader resource view description here. And we say it's a buffer. And we say that it has this many elements and this size. And this is just my buffer of UI elements, which is what I'm going to draw on the screen. I do this sort of like one draw call UI kind of thing, which I looked a bit at the last stream, but I have sort of implemented it a bit more since then. But anyways, so it uploads, it copies, well, it doesn't copy them in here, but it makes the shaded resource view here. Chat asks, haven't seen the arrow operator in Odin yet. What does it do? Lamato said it used to determine the return type, set the return. No, I think it's the confusion there. Yes, there is this one, that's the return type. I think what Adam is referring to is the one I use here, right? And that one is a special for sort of object-oriented COM style things, or whatever you want to call them. So on, for example, we have create committed resource here. So here's the device. This is a D3D12 device, and create committed resource. We will go to D3D12.Odin and look at create committed resource. Then we see that this thing here lives in the iDevice because there's a using blah 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 here. But so you can see this procedure here. This is a procedure pointer that lives inside this object because there's a using here. So all this stuff gets put into here. They just split up for organizational purposes, really. So create committed resource here takes a pointer of itself. There's a this pointer here, and what it just does it feeds in. If you call it with the arrow operator, it takes the thing to the left of the arrow and feeds it into here. It's just syntactic sugar for feeding the object itself into the procedure as first parameter. So you see, this one, if I did this, I would have to write like that. Or like that maybe, but I don't have to because I use the arrow. It was put into the language to make interfacing with many of these Microsoft style APIs easier, because they use so much of this API with a thing that you could use it for your own stuff if you have like this kind of API style thing where there's an object that has But keep in mind, this is just for, this is for an object, this is for an instance of a struct that has struct pointers inside it. It's not gonna work for like, if you have a package called the D3D12, I mean, it needs to be the object type itself. These procedures are on the object type device, and they are pointers to procedures in here. So you need to fill out like this. The Direct3D API does this for us, right? It fills these out with this API here. But it's for, you can use it to create dynamic APIs where you get different APIs that do different things depending on. You can like fetch an API, and maybe Direct3D uses this a lot to have, there's different API versions, you know, and it can sort of load APIs sort of dynamically and stuff. But yeah, what I was getting to here was that the handle dot pointer in here takes plus equals get descriptor handle increment size times 1. That's because it's the second thing. So we had this, the second thing in the of all the descriptors, if you think of how this is laid out. Since there's one here, and then after it appends one more, there will be the second one we expect to be mapped to the second descriptor in there, in the heap. We would expect to be mapped to this because it's the first SRV thing in space 0. Anyways, so that's why there is a plus equal. We have no pointer plus equals on the other one. We have it here, so that it maps up correctly. So we can always think of it like the descriptor heap is just like a thing that you can just get the sort of a pointer. Essentially the handle is just a pointer to the first element, and then you increment the pointer and put to get to the correct slot in there, and you put it and you make sure that it matches up with the root signature and all that. Right. What we're gonna do here is I was looking at some shader reflection stuff. So we can look at the shader again, because currently it's hard coded that it goes into these, and I kind of want to somehow expose on the shader that, so you can say like, oh, I want to fill the constant buffer with this name, with this thing, maybe we'll start with this one and try to feed the MVP or this view matrix. This is just whatever all this does is currently scale the things so they're sort of on pixel size, and offsets it so it starts at 0, 0 up in the left corner. That's sort of what it does. It looks like this. You see here matrix scale, and it just like, this is the width of the swap chain, and this is the height of the swap chain, and then so it scales it a bit and translates it a bit. That's just to make it sort of work on a pixelish level. I don't know, I guess there's different ways to do that, but that's one way. Anyways, so I had this reflection stuff up and running. Well, I'm getting there. So we have this shader. I compiled the shader here. So this is my shader create procedure here, and I get the source here, and I compile it, and then at the end here I set up reflection, and this might need to be put behind some flag because maybe it's not available unless some debug stuff is happening, but we can do that another time. So I get some reflection stuff here, and using that I will be able to ask it what things are available inside, so I can maybe create a mapped naming and sort of feed things into there in a more nice way. I had a little blog post I was looking at. I'm gonna try to find that again. Here's a block, but I think this might be for D3D11, but as with many things, D3D11 things work, and unless it's about descriptors and some other things, it might sometimes work as a starting point. So this person talks a bit about what you can do with reflection and stuff. And I was down here looking at the shader description. Get input parameter desk. Okay, but we're more interested in shader input bind desk. Let's have a look if we can do that. I think, okay, this is for D3D12. It's just, yeah, it is for D3D12. I'm gonna toss the chat out a bit because it's in my way. Put this here, that there. Then we're gonna do some stuff. So we need to create sort of a mapping and store it in the shader so we can use the shader in sort of a more nice dynamic, like we can just query it for some stuff instead and set some, for example, that matrix that scales the view and stuff. So we will look at this shader reflection, get resource binding description. Okay. So then you say resource index I. Okay, what's the I here? Well, maybe it's just counted. We'll see. Is there a shader reflection resource? Guess resource binding desk by name. That's not very useful because we want to set up all the things so we know what we have before. Like we want to do this now. We don't want to look up by name later. Constant buffer by index, constant buffer by name. Shader bound resources. Oh well, we'll see. We'll see what this gives us. So this thing oh, it's in DXC. No, it's not. Oh, maybe it's in reflection. So there's an annoying thing about these COM API style things that I can't jump to symbol because it's not a symbol, it's a field of a struct, right? So this thing here has stuff on there. Get resource binding desk. Get resource binding desk, blah blah blah. Resource. Find some docs for this. See what it. No, not you. D3D12. I don't want the 11s. A shader consists of executable code, compile and a set of resources that supply the shader with input data. One resource set, blah 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 blah. Well. I guess this might. Maybe we can just loop over it, and when it returns something weird, we stop looping. Or something. So we need a D3D12.shader input bind description input desk. We can call that one. Let's see what happens if we put 0 here and we say here's your input desk. Let's just log.info input desk. See what that does. There is a name, constant buffers. Okay, it's a bit generic name, but if we change this name to Lala, then it says Lala here now. So that's the one. Return type dimension unknown, num sample space 0, bind count 1, C buffer bind point 0, bind count 1, uflex return type. What's the eye shaded reflection constant buffer? So what's the, can I check something here? What do you want? Eye shader reflection constant buffer. Eye shader reflection constant buffer. What's this then? Oh, it returns. It's peculiar. What does that do? Shader buffer desk. Shader buffer desk. I'm just exploring a bit to see what it does. Okay, so this one instead gave me also the name. It gave me the name and the size of it. The other one, resource binding desk. What happens if I do this? I just type a random number, 16, whatever. If HR is not 0, then we break. 0 means okay. We log.info input description here. We can stop logging this thing just to be less confused. Wait, what's happening? Oh, no? Wait. C buffer, flags 1, bind point 0. Oh, I'm still sending in 0. Lol. I was like, why is it doing? Okay. Here we see constant buffer, C buffer, bind point 0. Turn type mix. This one has gone sad. Bind point 1. Is this to be expected to be in the order? Type structured. Bind count 1. Shader input binder. So I kind of want. Let me check this thing again. Get resource binding desk. Get the resource binding desk. Yes. So this one loops over all the ones. So I guess you just need to fill. I guess you just need to fill out this stuff, the root parameters, make a list, and then make sure to put things into the heap in the same order. Then you're done, I guess. Hello, Brandon. Good morning. So, let's try that. We'll need some way to make a little mapping of these things. Hello, Aku. Just in the whole thing a bit. So what do we do? So let's try to get, it's a bit of I sometimes freeze up a bit when I do this kind of things because I feel like I have to do everything all at once. But let's do everything all at once then. So let's get the C buffer in and then map that one up somehow. We'll do that. Okay. Let's see. Root parameter. The only thing I need to know is essentially, I can make this a bit nicer as I go maybe, but you can look at the shader I have here, and the shader currently has some bytecode, which is how I saved away the shader code for putting into the pipeline and stuff. But then maybe we can do like shader put resources here or something. What is that we need really? I need a name, and I need to bind that name to a position somehow and put some stuff in there. We'll figure out exactly how that will work. Is it just a map from a string to an integer? Maybe that's all we need right now. We'll add more stuff to it as we go. Right. So we go here and we switch on input desk dot type, right? There's a bunch of things here. This is the part where I'm a bit I guess maybe I could just do like this. So Lamato said at the start, this looks like a lot of work to set up. And yeah, it's just, that's because it's so low level that you can do a bit whatever you want, which is why you can make it fast if you like. You can make faster code with these things because you have all the choice. Like the D3D12 doesn't choose for you how to set these things up, so you can do it in any way you want. You could, of course, if you do it naively, you can do something much worse than old school style. Like if you can do it much worse than like 3D11 would do automatically for your program. So that's, you know, also the backside of it. Maybe there's a name here. We just take the name and log it. We have constant buffer and UI elements. Okay, that's a good start. Let's do like this. We say, let's take the shader dot resource, and then we say strings dot clone to clone. We just clone it here, and we cast that to a string, so it counts the size for us. Input desk dot name, and you can use a standard allocator, that's fine. And then we map that to I. Yeah, and then we have, now that means now we have a mapping of those things. And then we also need to save away sort of the bind point, because we have the input desk dot bind point and the space. So here you have this, what they're doing here in this little blog post, hello Tabula, is essentially setting this stuff up, but doing it sort of ahead of time. Let's try, we can make this more general later. Maybe this can be I don't want to map it to a root parameter, but we can maybe do like shader, what's it called? I'll call it shader parameter, whatever. Space, integer, register, integer. Well, it's gonna come out as U32s from, probably, from D3D, so we can do that. And then we can do type equals D312 root parameter type, something like that maybe. Let's just try that. What am I typing? And then name is a string. No, wait, name we don't need there. I think, maybe not. Maybe like that? Maybe? So then we say it's like this. This is a shader parameter. The name, no, we don't have the name in there. We have the type is the no, we don't know the type yet. Okay, let's do like this. Type is a root parameter type, because this thing here I think has an input desk dot type. That's a shader input type, and that's not the same thing, but I guess there is a mapping kind of it. So we can do switch input desk dot type, and we can say case cbuffer. No. Why is everything bad? It just gave up there on us. Then we say that the type is .cbv, case.structured, then the type is .srv. think. And then case here we use panic. Implement me, because I only map these two right now, because that's all I have. Type is type. Space is input desk dot space. Register is input desk dot blah, 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 register. Now what's it called? Bind point. Okay, sure. That's what this thing says at least. I'm gonna trust it for now. Oh, maybe it didn't work because there was a compiler further up, so it got yeah. I thought my code was working, but it wasn't. Partial. Did you mean struct to red? Okay, so it's still compiling and running and all good. Because if it was like this would panic. Good, panics like I thought it would. Because it wasn't implemented, but now the two cases we have, which is C buffer and structured, is implemented, which is good. So we have that. So we have some kind of resource map. Now we have a mapping of a name to a thing. So somehow maybe now, let's remove all this crappy crap right now. Shader. Do I have a way to destroy shaders yet? No, okay. We can do that later. So that's that. Now maybe we can somehow bind this up and put some stuff into it. I don't know. So we have a main program here. Maybe we can just use this in the, let's try going to begin render pass, which I have named so nicely here. Do I use this T anymore? I don't think so. This was just a test thingy to animate some stuff. So I think maybe we could here, maybe, am I doing this correctly? Maybe. For we have the shader here. Do I have the shader? Which shader am I using? The shader is on the pipeline. I think. There's also a root signature here. Should I just make the root signature from what is on the maybe what I should do is just create these things here, these descriptor ranges, because I have the shader here. Maybe I can just create this based on what I have. Let's try this. So I was starting to do things down here. Let's instead go up here. And we say something like shade. And then we just make like descriptor ranges is a dynamic, we make dynamic D3D12 descriptor range context of temp allocate. We make a temp allocated array. We loop over all these and we append descriptor D3D12 descriptor range, and then we say range type equals v.type base shader register v.register num descriptors. Well, aha. Now I kind of need to know how many in a row there are. I guess. Why is there a num? What's the reason for there being a num descriptors here? Why can't it just be like one at a time? And then, because I still feed them into the descriptor heap just as it is. Like I just say like, oh, this, I just fill the heap offsets out. Oh well. We put this one to 1 for now, and then we try to figure out later, because it just will happen to work in our case. Offset in blah, 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 is D3D12 descriptor range offset append. So we do that stuff, right? Or range underscore type v.type descriptor range type. Oh, okay. SRV, UAV, CBV. Sampler. What is it I have? Shader parameter. I have a root parameter type. CBV, SRV, UAV. Okay. This is not this is, you can put constants or a CBV or an SRV on the root descriptor. It's the root signature itself. It's like one or two available, but otherwise you go via table. So this thing here should not be a root parameter type at all. It should be a, well, what should it be? It should be a root descriptor table range type. Fuck it, I'm just gonna do this. That's what I have right now. I know this is probably not going to be correct because you have a range of them. I currently have only one, but we'll see. This might look a bit weird because it looks like I'm saying the same thing, but this is implicitly of this type, while the other thing here is implicitly of my own type, the shader parameter type thingy. So now I put these things in a dynamic array here that I temp allocate. So I just fetch the raw data of that to get a pointer to the start, and then I say how many there are. That's how the C API there works. And now we just need to go up here, and we need to say instead shader parameter type. And that still worked, right? We just replaced the this thing here with this thing that's created from reflection. If we look at it, it says scripture range, range type SRV, range type CBV. Oh wait, it's black. They came in a different order now. Ah, wait, the yeah, I can't do the thing I just did is very weird because I just put them into a map, and the map is, you know, it's not sorted. It's not sorted in the order they came in there. I just put that like that because I thought I would do some kind of mapping. Because I'm just trying things as I go. But yeah, the order must be correct. So let's see. So sometimes it is black like this, and that means they're in the wrong order, and sometimes it's not black like that. Sometimes it's, well, now it's always like that. How many times? There you go. Now it's gray with a little less dark bar up here, which is my first UI rectangles that I've made. I mean, I can make this a list. It's just that I want, well, that's the correct thing to do right now. It's just a list of shader parameter like that. R dot type blah blah blah, and then we just do here instead append shader.resources. We append a shader parameter apparently. I like that it's a resource and then it's a parameter, and I'll figure the names out. What? Oh yeah, of course. Yeah, this is not dynamic. I'm gonna make the dynamic list and then slice it. I'm just thinking here, or I'm just gonna make a slice and loop over it and fill it. But I'm thinking what the name should be. Shader resource. Is that the correct? Yes, that's a better name. This is not really a resource type, the CBV SRV. It's more of a resource binding type. I don't know. Oh yeah, and then this wasn't, of course, a... Can I get a list of how many there are? Or is that just not allowed? iShader reflection. What's that one? Get resource binding Where is it? What's the name? Get resource binding desk. Okay. There it is. Okay, that one does not have. It only has an index. Maybe maybe the shader description says how many there are. Constant buffer, bound resources. Maybe that's what we need. Right. Philip is asking a question here. Oh, this is about your own code. Pre-compilation I scan structs for custom attributes, for example, asset, and create a type ID array. How would I make my engine asset register the type ID if the types are declared outside the asset registry pack? I don't remember exactly how it works these days, but I think type IDs might not be stable across different compilation units or something. So essentially you cannot use type IDs, but maybe that changed. I don't remember, because there was some discussion about it recently. But I would probably make it less generic. Like have an array of textures, have an array of sounds that has just a struct type of your own. It's probably easier, and then you can loop over those and load them and stuff. That's how I would do it. Because I wouldn't, yeah. Yeah, that's at least how I think I would do it. Right, so what I was doing here was I wanted resources. Is this how you do? Num resources is shader desk num bound resources. Is that it? Resources is make shader resource num resources, like that maybe. And then we say for then you loop, then you say resources I equals, and then you say shader dot resources equals resources. You go up here and you change the name because you misspelled it, and then you say binding type. And now it works correctly on each, because now they're in the same order, right? So that's one thing sort of eliminated. We still have a 1 here. This is gonna come back and bite us at some point, but I'll just ignore that for a bit. So now we have this thing where we want to update the so-called model view projection, and this shouldn't even happen in here because this is inside my renderer file and I have my main file here, and because perhaps out here it should calculate that stuff. And this is maybe not even it's not really we can give it a better name at some point, but it's sort of a view matrix, I guess. Yeah. Let's change the name now then. Constant buffer view matrix. That. I think that I have transpose here is maybe a sign that this should this maybe be like, how did you do this? Row major. Oh, no, it exploded. No? Is that not the problem here? Maybe I'm just yeah. I think that's how it should be. That the matrix in D3D12 is different from the one that the linear algebra stuff in Odin does. But we can also just do like this maybe. What do we use math for? Nowhere. Well. Okay, you can choose row major, swizzle, or whatever. So maybe we can just do this instead. Mat4. That of course works. Then we just do like this. So mat4. Yeah. You can of course do a cast here and it will automatically do the correct. It's just a bit annoying. It's a bit annoying that when the API you're using is not using the same convention as the linear algebra package, then there's some HLSL. What does that one do? I never used this one really. Oops. Well, I don't know. I think this is just because the way all the linear algebra stuff works in the linear algebra package here works fine with how things are set up by default in some things like OpenGL, I think. But with D3D you have to flip it. Flip the storage, which is fine. I mean, you would probably hide this behind I would probably make it so that if I have an engine, I will do it in the Odin linear algebra way and then flip it inside somewhere. But yeah, so we can just do this maybe. Let's just do that for now. Anyways, that was not what we're doing. We're gonna remove this thing so we don't have, well, yeah, we're gonna remove this stuff and we're gonna map it up somehow. How do we do that nicely? Constant buffer. These things you can spend like an enormous amount of time on, I guess, because you could also make like a description, expose from your render a description of the fields, so that you say like, oh no, okay, this is a matrix, 4x4 matrix, and then you make a little API that accepts that, which is of course maybe what you should do. This is hacked in here currently, the constant buffer resource here. This needs to go. So I instead need to create a resource and then map it up somehow. And that's the other part here with the handles. So how do I do that? It's essentially just fetch a name of something, constant buffers, and say, hey, I want to map this with this GPU resource, and then it has the index and something, and then it works, I guess. We'll see. So what we can do instead here is this. We can out here say because I have a way to create buffers already. And then I just need number of elements. One element size is size of constant buffers. I don't know why it's called constant buffers, but yeah. And then we take that thing and we put it somewhere. We can just put it here next to it. It's fine. Right? So we have a little thing here. Then we have, that means we have a buffer here, a buffer handle. This thing I made, it sort of has a handle to a buffer, and the handle is just sort of it's a standard handle map thingy with an index and stuff. And yeah. And this, you see, looks very similar to the stuff we have over here. So hopefully we can just take this, comment it out. I can copy it to the main file, so I have for a reference. We'll try to. This is, I kind of like working like this. You know, you start with something hard coded, for example, in this case in the renderer, and then we sort of backtrack, you know, and get to the more general approach when we need it. Okay, so we have done this part now. We haven't made the handle thingy, but that stuff, I think we can do. Yeah, we can do D3D12.mat4 like that. What's wrong with that? Oh. No. It's called ren. Size of constant buffer. And then we can map it up, cbuff map, and the buffer map. And then we toss in that one. We have a mapping here. That's what we used to do in the, we used to type MVP. No, it was called view matrix now. This stuff here, we can cut out from there. And we'll put it here or something. I think, yeah, it's possible to resize the swap chain. We can support that later in a bit, or maybe we can just do it right now. Window rect. What? Why is this one? Why is this one hard coded? Because it doesn't make any sense. Window width. Remove all this crap. Then we can just can you ask a swap chain for its size? Yeah, I guess that's what we'll do. So here we just do this. Reporting this backwards. All right. Copy this here. Rect dot width. Rect dot high. We can just do this instead. SW is F32 swap chain dot width. SH is swap chain dot height. Use it here. Swap width, swap height. Everyone's happy. Right, and then we have this one is moved. It's no longer in pip.constant buffer start. It's just cbuff map. That, and this of course doesn't work right now because it's not setting up the, I mean now it compiled and ran, but it's not setting up any of the bindings and stuff. Then we can also go here. This stuff here we can remove. Maybe you can just remove it right up. That. It still compiles. So now we just need to look at this part here and do that somehow. And this is the sort of where we need to glue things together a bit. And this is why I originally made a map inside here. Where is it? Here. I made a map originally so I can take a name, like a the name of the thing in the shader. Resources lookup is a map from a string to an int, and this is just the value is indexed into resources. So, and I keep them separate like this because I want this one to be sorted, I guess. Create shader, where is it? This one. Here, now I just need to do this. The X is whatever. We just do resources lookup strings.clone string, because it's a C string. So I cast it. I will count the number of characters and save it in the string. What is it called? Input desk.name equals I. That's just the index. Oh, we want in an integer. Oh, like that. Very good. So now you can look that up, which means I think you need to know how big the thing is, which is the big size of the constant buffer, and we need to know where it is on the GPU. That's the buffer location. So I guess let's just try here to do like set create constant buffer view. Okay, what do we want to do here? You want to say for this name, use this resource, use this buffer or something, I guess. Let's see. So something like ren.buffer and who are you? Where is this state saved? Begin render pass. Okay. What is this stuff here for? Oh, okay, this is just that sets up the this. We're gonna move this away as well. So maybe we can just do something like I'm just gonna write some stuff and see what happens. Set buffer, and then we say string name is a string, and then we say buffer handle. Maybe that's what I want, I don't know. And then we say if idx okay is, wait, we need a shader. All this, the state, this is the render state. Sometimes it needs the pipeline, sometimes the state. I haven't really figured out all these things nicely yet. Because the pipeline, sort of is, but at least currently, a pipeline is specific for shader. Because you feed in a shader handle here. So we can just do like this. So shader equals shader handle, and then we modify the pipeline to store that. And that means that we can go to buffer, set buffer. So maybe there should be no pipeline here instead, maybe. P dot, so, okay, yeah. Aha. Because this is something I've been thinking about, how you do it in a, how one would do it in a bigger renderer thingy, because I hand out opaque buffers to like handles, like here's a buffer handle, it's just an index essentially. Then I have my buffers, and my buffers are contain the D3D stuff here. Say that I multi-threaded this and could build rendering command, I could build command queues on several threads. Then these handles would need to resolve safely. But I only have the storage of the buffers is actually sort of centralized, right? So that's something to think about for the future. I mean, there's probably a million ways to do that, but yeah. So let's think here a bit. Well, you don't need to think about the buffers now. That's just something, that's just an aside. But the annoying thing is I can't get like, wait, pipeline, create pipeline. Right. So let's do like this instead. So we have the shader, then we go into shader.resources, resource lookup with the name. IDX, okay. And then, oh, it's a wait. Oh, wait. That may be. So then we have the index into that. And then maybe we can just do something like this. Constant buffer view description. Okay, this is this depends on what it is there. Okay, we're gonna need to. We can do this for now. I will change this to so it's shady resource view description if we pass on shady resource, but currently we'll test this for a constant buffer thingy. Constant buffer res. Right. Buffer handle. A buffer know how big it is, so we could also do like this: buff equals buffers p dot no h buff equals nil that is buff dot element size times buff dot num element. That's how big the whole buffer is. Push that into there. And this is the resource handle. Well, so you don't mix up the handles. This is the D3D handle. P.renderer.device, create constant buffer view. It maps it. Don't need to map it here. This is. We just need to create the view. Set buffer. Pipeline. Name. Constant buffer. So I'm just gonna do like this for now. Buffers. Buff. No, C buff. What is it called? Whoa. Oh. Pip device. Pip.renderer.device. Shader.resource lookup. Assignments. Resource lookup map from a string to an int. These errors are always, this is a bad error thing in Odin, that this error is the important one, but this one comes before because of, I guess it's before, if you think about where the error is, but assignment mismatch 1, 2, and I'm like, okay, but the reason this is wrong is because this doesn't even exist. So, yeah. Shader. I wonder if this should be a singular or a plural. Okay. Yeah, and this should of course then be the buff dot buff. Buff to buff. Here is some because I changed some things in the pipeline thingy. No. Render. Shader dot resources resource lookup. That seems to work. Did I work on first try? Or am I imagining that it works? So I have set buffer. No, it works. Now it uses the name constant buffers, and that name comes from the reflection data. And I mean, I have made sure that if I just type anything here, it doesn't work, I think. No. So it's just because it knows that constant buffer goes to that one. Hello, welcome. Let's see. Okay. I said that what we're going to do then is that this is wrong, that it always has constant buffer udes because it might not always be a constant buffer. Okay. Because we have in begin render pass here, whatever it's called, we have this thing. And you can sort of see that this stuff here is very much what we're doing here. It gets a thing, but it's hard coded. It's currently passes it in here. So it gets a thing, but then it makes a shady resource view desk because it's not the same kind of thing. Oh, of course, there's another error here that here it should be times IDX, I think. Oh no. D3D12 handle dot pointer plus equals essentially this line needs to be there times IDX, because that's how far along it should like the offset into the constant the descriptor heap. And then okay, this cast needs to come inside there. There's a double. So I just cast this one to you into. I'm making just some D3D UI rendering stuff. Hopefully can make a little game editor out of it at some point, but I'm just taking it slowly and trying to learn D3D12 with all the descriptor heaps things going on. So this is currently, we currently have in, if we open render doc, for example, and start this and save a capture. Like one thing that I wanted to do early was to do the sort of one draw call UI. So we have that working. So we have the frame here. We clear the render view target and then we draw indexed ones, 12 indices. And this dark background and this less dark thing on top here. It may be not that visible on stream, but that's just because there's supposed to be a menu bar on top here later. But those are drawn in one draw call right now. And then of course we'll make more shapes and text and stuff at some point. But for now we're just doing basic renderer stuff and trying to figure out how to structure things. Yeah, but anyways, I added the handle pointer thingy here because it's well, not there, but we added it here in set buffer, because the way I've structured it right now is that the index of the thing, the index here or in the list of resources is the same index as in the root signature list. Do you make UI for your own game maker, like game engines UI interfaces? Well, I was thinking about trying to make, like, I'm just researching, like trying to create my own general purpose game engine, which is something I would like to do for a long time ago, like an open source thingy. But I haven't. I start with what I think is important, UI, like tools essentially, because many people want to make by general purpose game engine, I means something like Godot or something. Many people want to make something like that, and they start with, okay, I'm gonna do like fancy 3D rendering, physically based rendering, all that stuff. And that's, if you find it fun, that's good. But I also think that the majority of the code and the time spent on creating something like Godot is not rendering programming, it's tools programming. It's the tools that you use. That's the majority of work. So I just start with that. I'm not gonna have any, like I'll add small gameplay things and stuff like that when I need it. But we'll see. I'm just very slow. I mean, I'm just very slowly doing these kind of things, poking around. And at some point, of course, I would like to have multiple backends for the rendering. So maybe we can have direct 3D and Vulkan or Metal or something. But currently there's almost nothing, because I start with, like I said, with tool stuff. So we have a gray window with a toolbar on top, and we don't even have text support or anything yet. So there's nothing fancy at all yet. I'm just trying to figure the super low level basic rendering stuff out. Right. So what we're gonna do here is maybe we can do like this. We'll get the descriptor handle correct like this, and then we can switch res equals shader dot resources id x. We'll switch on that. Switch binding type case cbv case srv, something like that. And then we just do the appropriate stuff depending on the type. Now this should still compile and work. It does, because I'm not trying to use any of the this for this element drawing stuff yet. So we do srv description is, then we just take this stuff and we copy it here. So we have a buffer for component mapping. That is for doing some, if you have something that has less than 4 components per 32 bits, I think you can say that you want, for example, some value to always be 0, some always be 1. Maybe you can have a RGB color with the alpha always being 1. So you can, in the shader, it's a vec float 4. I think that's what it's for. But this is just the default. You just map them up as they should be. So maybe now wait, it's a bit weird this, because I have the buffer here. Hello, Mercurial Traveler. I have the buffer. Okay, the buffer is just okay. So the buffer has a num element and an element size. It's a bit weird because the constant buffer, it's not weird, but the constant buffer has the constant buffer just as a size, and of course this one has more of a how many elements, and because this one is sort of like a first this, like if you look in the shader, it's first one of these UI elements and then another one and another one, so it wants to know how many there are and how big is each, so we can sort of make a nice array of them. Mercurial Travel asks, anyone happen to know if GB is still planning on writing in native Odin GUI lib? I don't know. I think he was doing some game creation library for web at some point with Odin, but I don't know. He worked on this for a bit, but I don't know. Golden Lion asks, have you been working on another Steam game? No, I only did Cat and Onion. I poked around with some prototypes, but I didn't get very far, and I've been playing around. But And then I made a book instead. That's sort of what happened. I made a game, and then I tried to figure out what game to make next, and I couldn't figure anything out, so I made a book. Then when the book was done, I was thinking about making a game, couldn't figure something out again, so now I'm doing this. We'll see. I tend to work on a bit thing for a few months and see if it's fun or anything, and then we'll see. Why is it called D3D12? Is it a project coding? No, that's just direct 3D12. That's this file implements the renderer that uses direct 3D12, which is the rendering API on Windows for the rendering API called direct 3D12 on Windows. Just like Vulkan or OpenGL or whatever you might have instead that you can also use. What were we doing? Direct 3D is okay. It's certainly more fun to use Direct 3D12 than to use Vulkan, because it's just less. It just feels more straightforward to use to me. I've tried using Vulkan. It wasn't that fun. But maybe it was a skill issue, as they say. Anyways, this works. Now we just need to go to begin render pass, where we currently pass the elements buffer. The elements buffer is, we have a UI file here, and the elements buffer is the UI elements. Currently it's just rectangles, but this is essentially the elements that are going to be drawn on the screen. And I make a buffer for those, and then I commit them into that buffer by sort of copying into a memory mapped thingy. And that's what's supposed to go into this buffer here. So we have all that set up. We just need to map it up instead, I think. Maybe it will just work now. So we go here and we just remove. We go here and we just remove this parameter completely. Will you also use OpenGL and Vulkan? I will probably not use OpenGL because I'm trying to use some more low-level rendering things. Vulkan, maybe if I do for Linux, a backend for Linux, and then maybe Metal on Mac or something. We'll see. I'm not. This is just. I'll do one of those, because at some point you'll be like, okay, now I need to. Now I want my rendering backend to support. Like no, now I want to support multiple rendering backends, which means now I want to support both Direct 3D12 and something else. And one reason to do that is because you early on want to make sure that your renderer, if you're making a sort of a general purpose thing, you want to make sure that it's a bit future proof, in the sense that you can, when you need to, you can add more render backend. So we might as well add one slightly before you need it, just to make sure that you haven't. It's quite easy to start making your renderer, and if you only have one render backend like Direct 3D12, then things, Direct 3D12-ish things leak out through it's like becomes a leaky abstraction sort of, and then it's very hard to use anything that's not Direct 3D12. But that's a later problem. So I think we can just remove this. We can go to the main file. I'll paste it in here for reference, but I think if we now compile and run, it will be black or crash. Black, good. And then we go here and we say run set buffer pipeline, and then what's it called? Shader.glsl is called UI elements, and then we say UI.element buffer, and it didn't work, so we try to figure out why. Set buffer. What we can do is go to, does it get to here? Yes, it does. Wait, there's no there's no call here to actually use this. It's just that there's your problem. Main, I have this here, right? Create shader resource view. This thing needs to be here. So create shader resource view. This one wants the resource, which is buff.buff, and it wants the srv desk, and then it wants the handle. There you go, now it worked. So now this uses a name to map it up. Maybe, of course, I should not have a name here, because looking up names is not the fastest thing, so maybe you would like a handle as just an index that goes into a thing instead. I will think a bit about that. But now, that's cool, because now if you go into render D3D12, there's no, as far as I know, there's currently no hard-coded things in here really. I mean, it only supports my own UI stuff. It doesn't support any 2D or 3D game rendering really because of how it's set up. But it's a good start, because we are able to sort of load a shader like this, feed in the shader source here, load it, and that uses reflection to find the different constant buffers and structured buffers and stuff in there, and with the names, so we can map them up. And then we still don't have any of the input layout. That's you can also do using reflection, but anyways, this is all the code that was hard coded that came out of my render that I can now delete because it's in different places. Yeah, good. Has some leaks, of course, here. Can fix those. Oh, one nice thing I did since the last stream is, you see down here is the Odin memory leak, and I also put in the direct 3D memory leak report up here. So when I get the you can report live objects, so it's all the objects that haven't been released in direct 3D12. So it's essentially, this is my CPU side stuff, CPU side leaks, and up here we have GPU side leaks. These are a bit harder to find because you don't have a nice line number of where it happened, but at least it can be like, okay, there's a resource, what resource have I recently added, and then you can try to figure it out. I think you can name these. I could give them names, so it pops up here. I just haven't. There's some way, I think, some set name on resource or something. That's for debugging. So I know exactly what it is. It's these are easy to look at. Like 700. What was it? Oh no, I closed everything. 822. Okay, this is a string clone, and then there's several things here. And then there's a 79797. That's the list of resources. Okay, all these are part of the same thing. I think we'll just make a little this shader. Let's just make a little arena for that. So we can just have free one thing instead of. This one I will temp allocate. The reason I do that is because I will clone it out because... No, wait, I don't need to. I thought it was a dynamic array. Arena. Resources arena is a... init. It's fine. No. So we passed. Oh, well, this is. Yeah. That, and then we put, where more do we do this? Shader.resources resource lookup is make. When does Win10 go end of life? October or something? And I'm running Win10 as some, as you might see, because my computer, I have a very fancy desktop and it doesn't support Win11 because of their TPM requirement. I have one of a super beefy i7 that was the last generation to not have a TPM chip. So I guess I'm quitting Windows in the fall. That's just, thank you. Microsoft things. Now there's only 2 leak, and then of course I'm going to destroy the arena at the end, but clone string resource arena, and then there's how did it go from? Oh, because both, there's 2 of them, of course. Lock. And then we make a buffer destroy, no, a buffer destroy, but a shader destroy. Yeah, shader destroy. It's a procedure that takes a What does this one take really? I guess it's... Yeah, I'll try some. I mean, I've used Linux a lot over the years. I've used all the different many types of Linux desktop and also Linux servers and stuff. And I've used Mac OS a lot. So I sort of used all major operating systems a lot. All of them, I wouldn't say that anyone is very good. I think all of them are bad in different ways. It's usually what the problem with them. So, but yeah, I mean, I had a period where I, for a long time, used Arch Linux, for example. I kind of like the minimalism of that. But maybe I'll try something more straightforward. Some people like stuff like Pop OS for Linux stuff. I don't know. We'll see. Oh. And then we also need to start like that. Of course, this doesn't do anything yet. So we'll go to main. Maybe that's a bad use case for an arena. I don't know, but. Go. So what's the last thing there now again? It's this D3D resource. It's this buffer. I think. Yeah, now it's clean. Yes, pray that Ryan ports rad debug before October. Yeah, I guess that's the usual problem with using Linux. It's not which desktop environment is good or which editor is good. It's that you don't have as good debuggers as Windows. Rad debugger and graphics debuggers, stuff like that. I don't know. It was a while since I used. I mean, maybe it has changed, but like people who suggest like, just use some front end for GDB. All of those I've tried is so much worse than a good sort of nicely tailored debugger and that you find on Windows, like Rad Debugger or even Visual Studio. Visual Studio's debugger is better than any GDB front end that I've ever tried. And Visual Studio is a debugger. People are making things like Rad Debugger because Visual Studio is not good enough. So in a sense, I still cannot. People have started making new debuggers for Windows to replace debuggers because they think they're too bad, and still. So Rad Debugger is like, oh, Visual Studio not so good, but you still can't have as good as Visual Studio on Linux. So it's not very good. But let's hope Rad Debugger goes well on Linux. That will change things dramatically. It's a bizarrely awesome open sort of. It's just there's so much stuff, like so much. I wouldn't say it's low-hanging fruit, but you know, it's there are obvious needs. I don't know how it's on the graphics debugger front. I use Windows here. I use RenderDoc, or I've also tried Pix a bit for Direct 3D. That's okay. Of course, you can't use like Pix on Linux. I don't know if there's something like RenderDoc that works, where you can inspect the draw calls and what happens on the GPU and stuff. But that part I haven't looked at much. Okay, I'm quite happy with that. We have something here where this is good. Let's see what we did. We did many things. We essentially did a sort of a resource. We do use reflection to make a list of resources and create the root parameters. Oh, so RenderDoc works on Linux. That's good. Then, as long as we get RAD debugger and RenderDoc works well on Linux, then things might be good. I would say. Yeah. We cut out some hard-coded stuff from the rendering code. That's good. We have used reflection to make these shaded resources, and we use those to make our Emil Nordgård says, I can technically open RAD debugger on Linux, but if I do any action, it will crash. Yeah, but yeah, I guess it's work in progress. But at least he's aiming for getting it there. I really think that there's so many people who dislike Win11 that there, you know, there's the meme about this is the year of the Linux on the desktop. I don't think this is the year of Linux on the desktop, but I think there's so many programmers that dislike Windows 11, and with Windows 10 going end of life, there might be just a little bit extra push there for things like RAD debugger or something to make it all work. Anyways, so we have this stuff, this generic stuff here for creating resource views and constant buffer views and stuff based on the names and stuff. So that's all good. I'm happy with that. Used reflection to create generic constant buffer and shader resource view lists. They are used to create the root signet. No, that was it called the descriptor table. They're also used to map names in the shader to indices to pointer offsets in the descriptor heap. Wow, mouthful. It's just good to type it out sometimes to make sure you understood what you did. If anyone is interested in anything I did on the stream, then there's an open source repository linked in the chat now. It's also linked in the description. And also, if you want to learn more about the Odin programming language, then I've written a whole little ebook on it. There's a link to that in the description as well. That's it for today. That's it for today's stream. I think we did some nice things here with making things less hard-coded so that main.odin now controls how some things are fed into the shader and stuff. I'll keep poking around with this. Hopefully at some point there will be some text rendering, who knows? And we'll see. I just poke around a bit more with this. Thank you, Emil, for enjoying my book, buying it. Thank you. And thank you everyone for watching. Have a nice day and bye-bye.